For the 38th problem on this first ACT practice test, which of the following describes a true relationship between the functions f of x is equal to x minus 3 squared plus 2 and g of x is equal to 1/2 x plus 1, graphed below in the standard xy coordinate plane? So to solve this problem, we need to look at these different answer choices and see if they apply to our particular situation. So for these first two, you can see that f of x equals g of x, though for f, we're talking about for only two specific values of x, and for g, we're only talking about one value of x. So by looking at these two curves, let's mark them. So this top one here is f of x, and this bottom one here, this line, is g of x. So g of x is in purple, and f of x is in green here. So for these two functions to be equal to each other, graphically at least, all they have to do is cross each other. So you can see that the two graphs cross each other here and here. So we already know that choice F is correct, that these two functions are equal for exactly two values of x, namely whatever this value of x is and whatever this value of x is. But just to make sure we're right, let's go through the other choices and eliminate them. So choice G, to get a visual of what that would look like, if we had two functions that were equal for only one value of x, and let's say they're essentially the same functions that we're dealing with. So let's say this is g of x here, and let's say this is f of x. And for g of x and f of x to be equal at exactly one value of x, that just means that the two graphs touch at just one value. So whatever this x value is, this is the x value that the two functions are equal at. But as you can see, these two pictures are not alike. This f of x that we have does not just touch the graph, it actually crosses it and comes back up through it again. So we've eliminated choice G here. Now let's look at choice H. F of x is less than g of x for all x. Now if that was true, that would look something like this. Let's go back to our function here. And this time, instead of putting f of x above g of x, now we're looking at the scenario when f of x is always less than g of x. So that would look something like this. Notice for any x value you pick at random, let's say this one, g of x is always higher than f of x. But as you can see, that is not our case here, so we can eliminate h. And now for f of x to always be bigger than g of x for all x, it's essentially this situation here, but now let's say f of x is in red, and it would look like this, where it's always above g of x. Since if you were to pick any x value, let's say this one here, the f of x value is always higher than the g of x, no matter what x we choose. So we can eliminate choice J as well. And for choice K, f of x is the inverse of g of x. So this one is a little bit more complicated, but is still easy to identify if you know what you're looking for. So when two functions are inverses of each other, their graphs are essentially reflections about the line y is equal to x. So if we were to graph y is equal to x, anytime you have a function, its inverse will be the mirror image across this dotted line here. So let's draw a line. Let's say this is our function here. We'll call that g of x. And its inverse would just be an image across this line here. So here would essentially be its inverse. Since you can see they're essentially mirror images across this line y is equal to x. But as you can see in our case, these two functions are not inverses of each other. They are not mirror images across this line, which would be here, y equals x. So we right away figured out that choice F was correct, but just to make sure, we went through and eliminated the other 4 choices. So now we know that choice F is indeed our final answer.